Hey everyone, and welcome to my channel where we explore the wonders and terrors of the cosmos. Have you ever looked up at the night sky and felt a sense of awe and wonder, but also a tinge of fear? The universe, my friends, is not all about twinkling stars and majestic galaxies. It's also an incredibly violent and chaotic place. I'm talking about forces and objects capable of obliterating planets, solar systems, even entire galaxies, in the blink of a cosmic eye. So buckle up, space cadets, because today, we're taking a deep dive into the top 10 most dangerous things in the universe. We'll be exploring everything from mind-bending black holes to catastrophic cosmic events. Get ready to have your mind blown wide open. Let's kick things off with a bang, shall we? And when I say bang, I mean the biggest, baddest explosions the universe has ever seen. Gamma-ray bursts, or GRBs for short. Imagine this. A star, much more massive than our sun, collapses under its own gravity. In a cosmic blink of an eye, it transforms into a black hole, releasing more energy in a few seconds than our sun will emit in its entire 10 billion-year lifespan. That, my friends, is a gamma-ray burst. Now, these bursts are not just spectacles of destruction, they're also incredibly focused beams of energy. Think of a cosmic death ray shooting across the universe at the speed of light. If one of these GRBs were to occur within, say, 1,000 light-years of Earth, and if we were unlucky enough to be in its path, well, let's just say it wouldn't be pretty. We'd be talking about the Earth's atmosphere being stripped away, exposing everything on the surface to deadly radiation. It would be a mass extinction event unlike anything we've ever seen, perhaps even similar to what might have happened during the Ordovician extinction 450 million years ago. And if a GRB were to hit us directly, forget about it. Satellites would go blind, electronics would fry, and the ozone layer, our planet's protective shield against harmful radiation, would be toast. We'd be left vulnerable to the constant bombardment of cosmic radiation. It wouldn't be a picnic, that's for sure. But hey, it's not all doom and gloom. The good news, if you can call it that, is that GRBs are relatively rare events, and the chances of one occurring close enough to Earth to cause serious harm are, thankfully, quite slim. But it's a reminder of the raw power of the universe we live in. Next up, we're diving into the heart of darkness itself, supermassive black holes. Now, we're not talking about your average everyday black hole here. These behemoths are the undisputed heavyweights of the universe, lurking at the centers of most galaxies, including our very own Milky Way. We're talking about millions, even billions of times the mass of our sun, all crammed into a singularity, a point of infinite density. Their gravitational pull is so strong that nothing, not even light, can escape their clutches. Hence the name black hole. Now imagine our solar system on a collision course with one of these cosmic monsters. As we get closer, the gravitational pull on the side of Earth facing the black hole would become increasingly stronger than the pull on the opposite side. What happens next isn't pretty. We call it spaghettification. Earth would be stretched and distorted like dough being pulled apart until it's eventually ripped into atoms and consumed by the black hole. Talk about a bad day. And it's not just planets that these supermassive black holes can devour. Entire solar systems, even galaxies, can be consumed by these gravitational gluttons, leaving behind nothing but darkness and a faint echo of their existence. Take, for example, Sagittarius A*, the supermassive black hole sitting at the center of the Milky Way. It's relatively quiet now, but if it were to become active, it could wreak havoc on our entire galaxy. So, yeah, supermassive black holes are definitely something to keep a safe distance from. We've talked about the giants lurking at the centers of galaxies, but what's even scarier? Black holes that roam the cosmos like silent assassins, rogue black holes. These wanderers are not confined to galactic centers, they're out there drifting through the vast emptiness of space, invisible and unpredictable. Now, some of these rogue black holes formed billions of years ago, in the early universe, while others are the remnants of collapsed stars that have been flung out of their galaxies due to gravitational interactions. But here's the thing, black holes by their very nature don't emit light. They're invisible to telescopes and other instruments that rely on electromagnetic radiation. So, how do we even know they're out there? We detect them by their gravitational influence on surrounding matter. It's like trying to spot a ghost by the way it rustles the curtains. And believe me, these ghosts pack a punch. Imagine a rogue black hole, perhaps just a few times the mass of our sun, drifting through our solar system. Its gravity would disrupt the orbits of planets, sending them careening into each other or flinging them out into the icy depths of interstellar space. It would be pure chaos, and if one of those rogue black holes were to come too close to Earth, well, let's just say, we wouldn't even know what hit us. It would be a cosmic drive-by, with Earth as the unsuspecting victim. The scariest part? Scientists estimate that there could be millions, maybe even billions of these rogue black holes drifting unseen through the Milky Way. So, While the odds of encountering one are slim, the possibility is always out there, lurking in the darkness. Chapter 4. Hypernovae, when stars go out with a bang. If supernovae are the grand fireworks of the cosmos, then hypernovae are the universe's most explosive extravaganzas. We're talking about the most massive stars in the universe, stars over 30 times the mass of our sun, meeting their dramatic demise. Now regular supernovae are powerful enough, but hypernovae? They crank things up to 11. We're talking about explosions 10 to 100 times more energetic than your average supernova. These are the kind of events that can outshine entire galaxies for a brief, shining moment. But here's the catch, and it's a big one. Hypernovae don't just release a mind-boggling amount of energy, they also unleash those deadly gamma-ray bursts we talked about earlier. These GRBs, as we've established, are bad news for anything in their path, potentially sterilizing entire planets across thousands of light years. So, what would happen if a hypernova were to occur relatively close to Earth, say, within a few thousand light years? Let's just say it wouldn't be good for life as we know it. The intense radiation from the GRB would strip away our ozone layer, leaving us exposed to the full fury of the cosmos. And there's a candidate for a nearby hypernova that has astronomers a little on edge, Eta Carini. This massive star, located about 7,500 light-years away, is already showing signs of instability. If it were to go hypernova, and if its GRB were aimed in our direction, well, let's just say we'd be in for a rough time. So, yes, hypernovae are a spectacular sight, but they're a stark reminder that the universe can be a beautiful and terrifying place. Chapter 5. Magnetars, the universe's powerful magnets. Next up, we're talking about the universe's ultimate magnets, magnetars. Now, we all know what magnets are, right? Those things that stick to your refrigerator? Well, magnetars are like magnets on steroids, cosmic magnets so powerful they can warp the fabric of space-time itself. We're talking about a special type of neutron star, the collapsed core of a massive star, with a magnetic field so strong, it's mind-boggling. Imagine this, a magnetic field a quadrillion times stronger than Earth's magnetic field. That's a 1 followed by 15 zeros. To put that into perspective, if a magnetar were to magically appear within 1,000 kilometers of Earth, well, let's just say it wouldn't be pretty. Your credit cards would be the least of your worries. We're talking about atoms being ripped apart, the Earth's atmosphere being stripped away, and all life on the planet being extinguished in an instant. But even from thousands of light years away, magnetars can still pack a punch. These cosmic powerhouses can unleash intense bursts of energy, called magnetar flares, that can disrupt satellites and electronics here on Earth. Remember that time in 2004 when a magnetar located 50,000 light years away blasted Earth with a gamma-ray burst? Yeah, that was fun. It temporarily disrupted satellites and caused minor atmospheric disturbances. So while magnetars might seem like distant threats, they're a reminder that the universe is full of surprises, and some of those surprises are best admired from a very, very safe distance. Chapter 6. Rogue Planets, the Wandering Worlds of Doom. We've talked about stars and black holes, but what about planets gone rogue? That's right, folks, we're talking about rogue planets, celestial bodies that have been kicked out of their star systems and now wander the cosmos, alone and adrift. Now imagine this, a planet, perhaps the size of Jupiter or even larger, hurtling through the darkness of interstellar space. No sun to warm it, no star to light its way, just a cold, lonely journey through the void. These rogue planets are the orphans of the universe, cast out from their planetary systems by gravitational interactions with other planets or passing stars. And here's the thing, they're incredibly difficult to detect. Unlike stars, which emit their own light, planets are only visible when they reflect light from a nearby star. But rogue planets? They're shrouded in darkness, making them nearly impossible to spot with our current telescopes. It's like trying to find a needle in a cosmic haystack, except the needle is a planet and the haystack is, well, the entire universe. But just because we can't see them easily, doesn't mean they're not out there. In fact, scientists believe there may be billions, maybe even trillions of rogue planets roaming the Milky Way galaxy alone. It's a chilling thought, knowing that these invisible wanderers could be lurking in the darkness between the stars. And while the chances of a rogue planet colliding with Earth are astronomically small, the consequences of such an impact would be, well, catastrophic. It would be the ultimate extinction-level event, wiping out all life on our planet in an instant. We've explored some pretty terrifying cosmic phenomena so far, but now let's talk about the ultimate end game, the grand finale of the universe as we know it, the Big Rip. Imagine this, the very fabric of space-time, the stage on which the cosmic drama unfolds being stretched and torn apart. It sounds like something out of science fiction, but it's a very real possibility, according to our current understanding of the universe. Now we know that the universe is expanding. That's old news. But what's driving this expansion? That's where things get interesting. Scientists believe that a mysterious force called dark energy is responsible for this accelerated expansion. Think of it as the anti-gravity, pushing everything in the universe farther and farther apart. But here's the thing about dark energy. We don't know much about it, we can't see it, we can't touch it, and we don't fully understand its properties. But what we do know is that if dark energy continues to increase, as some models suggest, then the universe is headed for a rather dramatic end. We're talking about a scenario where the expansion of the universe becomes so rapid, so relentless, that it eventually overcomes the fundamental forces holding everything together. Galaxies would be ripped apart, stars would be torn asunder, and even atoms themselves would be shredded in the cosmic maelstrom. It would be the ultimate cosmic reset button, wiping the slate clean, leaving behind nothing but an ever-expanding void of nothingness. The good news, if you can call it that, is that this Big Rip scenario is still billions, maybe even trillions of years in the future. So, no need to panic just yet. But it's a sobering thought, knowing that even the universe itself may have an expiration date. Ever feel like you're being pulled in a direction you don't fully understand? Well, the Milky Way galaxy knows the feeling. We're on a collision course with something massive, something mysterious, something we can't even see directly. We call it the Great Attractor. Now imagine this. Our entire galaxy, along with hundreds of thousands of other galaxies in our cosmic neighborhood, all being drawn towards a single point in space, a gravitational anomaly of epic proportions. We're talking about a region of space so massive that it's pulling us in at a staggering 14 million miles per hour. But here's the thing. We don't know what the Great Attractor is. It's hidden from our view by the Milky Way's own galactic plane, a dense region of gas and dust that obscures our view of the universe beyond. It's like trying to figure out what's behind a curtain, but the curtain is made of billions of stars and spans hundreds of thousands of light years across. Talk about frustrating. So what could this mysterious force be? Some astronomers speculate that it's a massive supercluster of galaxies, a colossal collection of matter exerting a gravitational pull that extends across vast cosmic distances. Others believe it might be something even more exotic, something we haven't even discovered yet, a new type of cosmic structure perhaps, or even a hint of something beyond our current understanding of physics. Whatever it is, the Great Attractor is a stark reminder of how much we still don't know about the universe. It's a cosmic enigma, a gravitational anomaly that continues to puzzle and intrigue astronomers. We've talked about massive explosions and invisible forces, but sometimes the smallest things can be the deadliest. Case in point, cosmic rays. Now don't let the name fool you. We're not talking about beams of light or any kind of electromagnetic radiation. Cosmic rays are actually tiny particles, mostly protons and atomic nuclei, that zip through space at nearly the speed of light. Now these particles are incredibly energetic, far more energetic than anything we can create in our particle accelerators here on Earth. And that's where the danger comes in. When cosmic rays collide with atoms in our atmosphere, they create a shower of secondary particles that rain down on Earth. Most of these particles are harmlessly absorbed by the atmosphere, but some, especially the high-energy ones, can penetrate all the way to the surface, and that's where things get a little dicey. You see, when these high-energy particles interact with our cells, they can damage DNA, increasing the risk of cancer and other health problems. Astronauts who are exposed to higher levels of cosmic radiation in space are particularly vulnerable. But even here on Earth, we're not immune to the effects of cosmic rays. In fact, scientists estimate that cosmic radiation contributes to a small but significant fraction of the background radiation we're exposed to every day. And here's the thing about cosmic rays. They're coming from all directions in space. Supernovae, active galactic nuclei, even the Big Bang itself. They've all contributed to the cosmic ray background that permeates the universe. It's a constant reminder that we live in a dynamic and often dangerous cosmos, even if we're shielded by the protective layers of our atmosphere. We've explored dangers from the depths of space, but sometimes, the greatest threat comes from our very own backyard. And by backyard, I mean our solar system. That's right, folks, we're talking about the sun's eventual demise. Now I know what you're thinking. But Neil, the sun is our life giver. It provides warmth, light, and energy. How could it possibly be a threat? Well, here's the thing about stars. They don't live forever. Like everything else in the universe, they have a life cycle. They're born, they live, and they eventually die. And the sun is no exception. Right now, our sun is in its prime, happily fusing hydrogen into helium in its core. But in about 5 billion years, things are going to start getting a little dicey. The sun will begin to run out of hydrogen fuel in its core, and as it does so, it will start to expand, becoming a red giant. Now, when I say expand, I mean really expand. The sun will swell to such an enormous size that it will engulf the orbits of Mercury and Venus and Earth. Well, let's just say things are going to get toasty, the oceans will boil away, the atmosphere will be stripped away, and the surface of our planet will be scorched to a crisp. Not exactly ideal living conditions. But wait, there's more. After its red giant phase, the sun will eventually shed its outer layers, leaving behind a small dense core known as a white dwarf. This white dwarf will slowly cool over billions of years, eventually fading away into a cold, dark cinder. So yeah, the sun's death won't be pretty. But hey, we've got about 5 billion years to figure things out. Plenty of time to find a new home for humanity, right? So there you have it, folks, the top 10 most dangerous things in the universe. From gamma-ray bursts and supermassive black holes to cosmic rays and the eventual death of our own sun, the universe is filled with extreme dangers, many of which could wipe out life on Earth in an instant. But don't let all this talk of cosmic doom and gloom get you down. It's important to remember that we live in a relatively peaceful part of the universe, at least for now. The chances of any of these events directly impacting Earth in our lifetimes are incredibly small. But still, it's a humbling reminder that we are but a small, fragile species living on a small, fragile planet in a vast and often chaotic universe. So the next time you look up at the night sky, take a moment to appreciate both its beauty and its power, and be thankful that we exist in this brief moment of cosmic time.